There's a wall of concrete in central China that is currently making your days very, very slightly longer. Not metaphorically, scientists at NASA actually ran the math on this. And the strangest part isn't the dam itself, it's how they found out. In 2004, a magnitude 9 earthquake tore through the Indian Ocean. It was one of the most powerful earthquakes ever recorded. It was so violent that it physically shortened Earth's day by 2.68 microseconds and knocked the planet's axis sideways by about 2.5 centimeters. Two NASA scientists, Benjamin Fong Chao and Richard Gross, were studying that earthquake's effect on the planet's spin, and almost as a side note, they decided to run the same calculation on something else. Something man-made. China's Three Gorges Dam. What they found is the reason we're making this video. Stick around, because by the end of this, you're going to understand why some scientists have started talking about humans as a force on the same level as earthquakes and ice ages. I know that sounds dramatic. It's not. Let's get into it. First, you need to understand what this dam actually is. The Three Gorges Dam sits on the Yangtze River in China. It's 2,335 meters long, 185 meters tall, and when full, it holds back 40 cubic kilometers of water. That's roughly 10 trillion gallons. Picture every drop of water in a mid-sized American lake lifted nearly 600 feet into the air and held there permanently behind a single wall of concrete. It took over 40,000 workers and 17 years to build. It displaced more than 1 million people. It's the largest hydroelectric structure ever built by anyone, anywhere in human history. So when Chao and Gross took that volume of water and asked, what happens if you lift that much mass nearly 600 feet off the ground? The answer surprised even them. The dam slows Earth's rotation just slightly by 0.06 microseconds per day, and it shifts the planet's axis by about 2 centimeters. Now, here's where it gets interesting, and here's where you need a quick mental picture. Think about a figure skater spinning on ice, arms pulled in tight. She spins fast. Arms stretched out wide, she slows down immediately. That's not style, that's physics. It's called conservation of angular momentum, and Earth runs on the exact same rule. Pull mass closer to the planet's center, spin speeds up. Push mass farther away from the center, spin slows down. When the Three Gorges Dam lifted 40 trillion kilograms of water up and away from sea level, it effectively did the same thing as that skater stretching her arms out. Mass moved farther from Earth's rotational center. Spin slowed down, just a hair. 0.06 of 1/1,000,000th of a second to be exact. You will never feel this. No watch on your wrist will ever register it. But satellites can measure it, and it's real. Compare that to the earthquake number for a second. 2.68 microseconds from one massive earthquake versus 0.06 microseconds from the largest dam humans have ever built. The earthquake wins by a landslide. But think about what that actually means. A single human construction project, something with a budget and a blueprint and a ribbon-cutting ceremony, produced an effect large enough to even be compared in the same study, in the same units, to one of the most violent natural events of the century. That's the part that should stop you in your tracks. If your brain just did a little double take, good. That means you're exactly the kind of person this channel is for. Hit subscribe now, because we're about to take this idea somewhere most people have never even considered. Here's the bigger picture. For almost all of human history, the only things capable of physically moving the planet's mass around were natural forces. Earthquakes, volcanoes, glaciers grinding across continents over tens of thousands of years. Humans built civilizations. We farmed land. We fought wars. But we were never in the same category as those forces. We were passengers riding on a planet that other things shaped. The Three Gorges Dam broke that rule quietly, without anyone planning for it to happen. For the first time in recorded history, a single human construction project caused a measurable shift in Earth's rotation and its axis. Not symbolically, numerically, on the same scale that scientists use to measure tectonic plates shifting. And once you know to look for this, the dam stops being a one-off curiosity. It's actually part of a much bigger pattern, and the next example is even more staggering than the dam itself. Over the past few decades, in places like the western United States and northwestern India, humans have pumped so much water out of the ground for farming and drinking that researchers decided to check whether it was affecting the planet. A team led by geophysicist Clark Wilson at the University of Texas ran the numbers. And what they found, published in geophysical research letters, is honestly hard to wrap your head around. Between 1993 and 2010, humans pumped out roughly 2,150 gigatons of groundwater. And that extraction alone shifted Earth's rotational axis by nearly 80 centimeters. That's almost 40 times larger than the effect from the Three Gorges Dam, caused simply by pulling water out of the ground across multiple continents year after year, for normal, everyday reasons, like growing food. Then there's the ice. As glaciers and polar ice melt, that water moves from sitting at the poles, close to Earth's rotational axis, out toward the equator, farther from it. Same skater, same physics, same outcome. Researchers tracking polar drift have found that the melting of Greenland's ice sheet is actually the single largest contributor to this whole pattern, even bigger than groundwater pumping. The Three Gorges Dam was never the main event. It was the experiment that proved the concept was real. None of these individual effects would ever be noticeable in your day-to-day life. Add them together, though, and you get something that has genuinely never existed before in Earth's 4.5 billion-year history. A species capable of measurably altering planetary mechanics, not through one dramatic event, but through the slow accumulated weight of its own infrastructure and its own thirst. Here's what makes this genuinely complicated. On one hand, this is an almost unbelievable engineering and demographic achievement. We went from small farming villages to a species that can nudge planetary rotation in under 10,000 years, which, on a geological clock, is barely a blink. That's worth sitting with for a second because it's genuinely remarkable. But there's an uncomfortable flip side. Nobody set out to slow down Earth's rotation. The dam was built for electricity and flood control. The groundwater was pumped for crops and drinking water. Every single one of these planetary scale effects showed up as an invisible side effect of people solving a completely different, much smaller problem. That's the pattern. We solve an immediate need, and decades later, scientists discover what it quietly did to the planet underneath us. Sit with that for a second, not as something to panic about, but as something worth genuinely thinking about. We've crossed into a category that used to belong exclusively to earthquakes, volcanoes, and ice ages. We're not just living on this planet anymore. We're physically participating in how it behaves. If that idea lands for you the way it landed for me, drop a comment and tell me whether you find it exciting, unsettling, or honestly both at once. Because I go back and forth myself every time I think about it. A flood control project and some farm wells in California quietly reaching far enough to touch the rotation of the entire Earth is one of the most underrated facts in modern science. And almost nobody outside a handful of geophysicists ever talks about it. So next time somebody tells you that human achievement stops at the surface of the planet, tell them about the wall of concrete in China and the wells in California and India. that reached all the way down to the spin of the Earth itself and changed it just slightly for good. If stories like this, the moments where ordinary engineering quietly collides with planetary-scale physics, are exactly what you come here for, subscribe now because there's a lot more of this kind of thing where this came from.